Okay, hello. So we're going to look at today at the last few circle theorems. It's just one, but it's got two versions of it. So we are going to have a look, and it is called the intersecting chords theorem. And would you guess why it is called that? Yep, you got it. Because there are two chords in a circle that intersect each other. There you go. So here's my circle, that's my center, and I got two chords, one and the other, and they have to cross. In order for the intersecting chords theorem to work, the chords have to cross. Now, what the intersecting chords theorem says is that that distance there of the first chord multiplied by that distance there has to be equal to that distance there multiplied by that distance there. So that's it, really. So the example would be, let's change color. Right. If this was 3, that was 6, and then this bit here was 9, and that would be x. The question would be to find what's the value of x. Well, the intersecting chords theorem tells me that 3 multiplied by 6, so the two halves of the first chord multiplied by each other, so that bit there times that bit there, 3 times 6, must equal the first bit of the other chord multiplied by the other one, so 9x. And this is very straightforward. 18 equals 9x, therefore x equals 2. And that is the intersecting chords theorem. That is it. There's another version that we're going to look at in a minute. Okay, and here we have the variation of the intersecting chords theorem. Here we have two chords that intersect, but as you can see, they do outside of the circle. So, what the intersecting chords theorem tells us when the two chords intersect outside the circle is that the total length of the chord times the portion outside is equal for both. So, here we go. What this tells us is that AC, so the whole chord from A to C, times the portion of that chord that is outside of the circle, so BC, must equal the same thing for the other chord, DC, which is the length of the whole chord, times the portion outside the chord, EC. So let's put some numbers in there so we can see how this works. So let's say that AB is 4, BC is 6, and EC is 3, and we want to find the distance DE, which is x. So if we apply the intersecting chords theorem, so the whole chord AC, well, that's 4 plus 6, which is 10. So 10 times the portion outside, which is 6, must equal DC, which is the whole length, we don't know what that is, times the portion outside, which is 3. So 60 must equal 3 times DC. Therefore, DC equals 60 divided by 3 is 20. Now, DC is the whole chord. I only wanted to find DE. Well, if this is 20 and EC is 3, DE must be 17. And that is the intersecting chords theorem when they intersect outside of the circle. There you go. That was all. I hope that was helpful. Copy the examples out. Please let me know if you got any comments or any questions, and we'll take it from there. Bye.